So in this video we're going to look at another observation I made today through the head-up display while flying west as the sun was setting. And as you can see, the position of the sun is clearly below the horizon line. Now this is a little different to my moon video because this video was taken while the aircraft was in a descent. And we're going to talk a little more about the symbology in the head-up display and how it actually works, because flat earthers have been desperately trying to discredit my moon video, but all they keep doing is proving that they don't understand what they are looking at. So let's explain a little more about how this head-up display works, and you will understand why the flat earthers just keep getting it wrong. So I've made a few notes here just to summarize the points that we will cover. Firstly, remember the horizon line is showing true level. At high altitude, this is above the visible Earth horizon. Let's go to the aircraft flight manual and see what it says about that. So this is the Global Express Flight Crew Operating Manual. It's called the FCOM, and this is volume 2, which covers the operation of the head-up display. You'll see it's over 1,300 pages, and the page we're after is 786. So we'll go straight to that. It's the head-up display system, HUD, if installed, continued. Specifically, the horizon line. The horizon line is conformal to the external scene. However, it appears above the natural horizon at high altitude due to the curvature of the Earth. And this is the horizon line. In my video footage, you can see the horizon line is clearly above the visible Earth horizon. And as the flight manual says, that is due to the curvature of the Earth. So still talking about the horizon line, the second point is the nose attitude of the aircraft will not change its position relative to the visible Earth horizon. In this photograph, you can see the horizon line is clearly above the visible horizon. Now the aircraft was in a descent when I took this photograph. We had 6,000 feet set in the pre-selector, and we were passing 13,180 feet as I took the photo. The nose attitude of the aircraft is indicated by this W symbol, and there you can see it is about 2 degrees below level. This is the pitch scale, that's indicating -5 degrees, and this is indicating -10 degrees. So this is the nose attitude of the aircraft. It is indicating nose down, and yet the horizon line is still above the visible horizon. If I were to put the aircraft into a climb, this W would move above the horizon line, but the horizon line would not move relative to the visible Earth horizon. That's one of the mistakes that many flat earthers made. They believed that by pitching the nose of the aircraft up, this horizon line would move. That is not how it works. And the third point is that moving the camera up and down will not affect the position of the horizon line relative to the Earth's horizon. This is another misunderstanding that some flat earthers have. So today, I took some footage moving the camera up and down, looking through the HUD, and you will see that it does not change the relationship between the horizon line and the visible external horizon. As you can see, I'm moving the camera up and down, and the position of the horizon line relative to the Earth's horizon is not changing. And the fourth point is that directions in the head-up display are in degrees magnetic, and therefore you must use the local magnetic variation to convert back to a true direction if you want to make an analysis of the angle of the moon or the sun. You cannot look at MoonCalc or time and date, which provide a true direction, and expect to see the same reading in the head-up display. because depending upon your location on the Earth and the local magnetic variation, those angles can be quite different. And any pilot will tell you that this little memory aid is very useful. If the variation is east, magnetic is least. If the variation is west, magnetic is best. So let's take a look at that. So this is the time and date website for Perth, Australia. You can see the local time is 10:05 p.m. on the 12th of April 2019. My laptop is still on Sydney time, which is 2 hours ahead, so it's already Saturday the 13th of April. Now today in Perth, the sun set at 5:59 p.m. in a direction of 280 degrees true. In this photograph, you can see that the position of the sun is slightly more than 280 degrees. This W represents west. There we have 280 degrees, and this small marker shows 285 degrees. So it's slightly more than 281 degrees, but not quite 282 degrees. And remember, this is because the head-up display is indicating degrees magnetic, but websites such as Time and Date or Mooncalc are showing the true direction. So the only way we can understand why they are different is to look at the magnetic declination. Now, at the point where I took this photograph, we were still east of Perth on descent, and the magnetic declination in this location is -1 degree 17 minutes. So it's slightly more than 1 degree west variation. Remember, variation west, magnetic best. So if we have a true direction of 280 degrees and a variation of 1 and a bit degrees, the head-up display is going to show a direction of 281 and a bit for the position of the sun. And as you can see, that is absolutely perfect. So remember, directions in the head-up display are in degrees magnetic. There is one flat earther who got very excited because he thought he found an error in my video. The angle of the moon in the head-up display did not match the angle shown in Mooncalc. However, he made a rookie mistake by not understanding the difference between magnetic directions and true directions. And when you applied the variation in that particular scenario of 13 degrees east, it actually matched perfectly. So I'll play the footage taken today, and you will see very clearly that as the sun is setting, it is below the horizon line. And that means it is below eye level, below true level as it is setting. And that is impossible on a flat Earth. The only reason we see this scenario is because the real Earth's horizon has dropped when we're at high altitude due to the curvature of the Earth. Now, I made a point also of looking at the aircraft clock, which is a precise time in UTC. And there we have 1000 UTC. Now remember, the sun set at 5:59, and that is 0959 in UTC. So this is now after the sun has set in Perth, which is actually further west than our present position in this video, and yet we can still see the sun because we are at a higher altitude. Yeah, now it's handling it okay.
6,000th shift.